Hello students, this is your course teacher Masaratu Nisa. So today I'm going to teach you the nodal analysis. So as you can see in the circuit, find nodal voltages for the given circuit. So as the circuit is given and you need to find the nodal voltages for this circuit. Before we start, you first have to identify the number of nodes present in the circuit and what is a node. Node is a point where two or more wires meets. So here, as you can see, let us first identify the number of nodes in it. So here this is one node. Because these three are connected in parallel, the voltage in parallel remains same. Then there will be a common one node for all the three because they are connected in parallel. If they are not connected in parallel, then you can take separate nodes for all three of them. But since they are connected in parallel, we have to take one node for all three. So this is my node. This is my first node. I'll be assigning some voltage to this node. Let me assign the voltage to this node as V1. Okay. Now next there is another node over here. This is node 2 and the voltage at node 2 I'll be taking it as V2. Okay. And since these two are not connected in parallel, because you'll be having 25 ohm in between, for that reason these two are regarded as two separate nodes. So let us go to node 1. What you have to do is you have to apply KCL to node 1. So let me apply KCL at node 1. So before you apply KCL at node 1, KCL means Kirchhoff current law. So you first have to identify the number of branches connected to the node. Okay, since we'll be at this node, then 1, 2, 3, 4. The four branches are connected to node. And if you don't know the direction of current in particular branch, like if this is a branch connected to node 1, and if I don't know the direction of current in this branch, then I have to take the direction of current as it is leaving the junction. Next, another node. This is another branch in which the direction of current I'll be taking it as it is leaving the junction, and the direction of current in this branch it's already given as it is entering, and the direction of current here in this branch is still not there. Then I'll take it as it is leaving the node. Okay, now let me take the sum of the currents in all the branches connected to a node. So here as we don't have the value of current, we have a value of voltage and resistor. With the help of a value of voltage and resistor, we can take the value of current. So the value of current in this branch will be V1 by 30, because the voltage in this branch will be V1 and the resistor of this branch is 30. So the current in this branch will be V1 by 30, and the leaving voltages are taken as positive and the entering voltages are taken as negative. So I'll be taking plus V1 by 30 is the current in this branch. What is the current in this branch? The current source is already there. It's already in current form. You need not to take V by R. So this is as this is entering the node. So I'll be taking it as minus 4. And since you don't have a value of current over this branch, so again I'll take it as V1 by 15. So since it is leaving, so I'll take it as plus V1 by 15. And here V1 minus V2 by 25 plus V1 minus V2 by 25. Since I am at node 1 and this node is connected to 25 ohm branch. So here and this 25 ohm is connected between two nodes. So you have to take potential difference, that is V1 minus V2. And since you are at node 1, for that reason you have to take V1 minus V2. If you are at node 2, you have to take V2 minus V1. And since this is leaving, I'll be taking it as positive. So it will be V1 minus V2 by 25, which is equal to 0. Let me just combine the terms of V1 and V2. This is 1 by 30, 1 by 15, 1 by 25. And the terms of V2. What is with V2? Minus 1 by 25. That is equal to constant. This constant goes there. It will be plus 4, and this I'll be taking as equation number 1. Now let me apply KCL to node 2. Let apply KCL at node 2. So I go to this node. How many branches are connected to this node? There are 3 branches, 1, 2 and 3. There are 3 branches connected to this node. So this the current in this branch, it's already given. The direction of current in this branch is leaving. The direction of current the direction of current in this branch is not there, so I'll be taking it as leaving, and here also leaving. You need not to take the direction of current which you have assumed for node 1. When you are at node 2, you have to assume a new current for node 2 which is leaving the junction, okay, which is leaving the node. So here the value of voltage in this branch now at node 2, if you are on node 2, the value of voltage, the value of current in this branch will be V2 minus V1 by 25. So it will be V2 minus V1 by 25, and since there is a form of current over here, you need not to change it to V by R. So you can directly take it as plus 6, and this is also plus because it is leaving. And next V2 by 20 plus V2 by 20, since it is leaving, which is equal to 0. There are only 3 currents and the sum of the 3 currents is equal to 0. Okay, let me combine the terms of V1, V2 and V3. V1, as the coefficients of V1 are minus 1 by 25, the coefficients of V2 are 1 by 25 and 1 by 20, which is equal to 0. This is equation number 2. So let me solve equation 1 and 2. Let me solve equation 1 and 2 using calculator. So I'll be taking a calculator. Now I'll be assigning some settings to the calculator. That is, I'll press mode. First switch it on, then press mode, and then go to equation, then press 1. Since it is x plus y is equals to constant equation, so press 1. Then you need to enter the coefficients of V1, then V2, then constant. V1, V2, then constant. The coefficients of V1 are, here the coefficient of V1 is 1 by 30 plus 1 by 15 plus 1 by 25 is equal to, the coefficient of V2 are minus 1 by 25 only, and the constant has to be on that side as per the settings of a calculator. So it will be 4. Now let us go to the second equation. The second equation, the first coefficient V1 coefficient, V2 coefficient, then constant. So the coefficient of V1 is 1 by 25 minus 1 by 25 is the coefficient of V1, and the coefficient of V2 is 1 by 25 plus 1 by 20 are the coefficients of V2, and plus 6, if it goes there, becomes minus 6. The constant is minus 6, so it will be minus 6 here. And let us now press equal to, so that you can get V1, the value